Problem number 5. Noah is growing 3 different types of trees. He is keeping track of the height of each tree over time. This equation represents the height in feet of the tree number 1 over m months. H equals 3.5 m. The information in the table is for tree number 2. So this graph shows how long in months it takes tree number 3 to grow h feet. And here we have a graph for it. So we are really comparing tree number 1, where they gave us the equation. We are comparing that with tree number 2, which is given to us as a table. And the last one we have is tree number 3, which is given to us as a graph. And our first question is, which tree is growing the slowest? Well, we want to, again, focus on the slope when we're thinking about the constant change. And so the slope for tree number 1, when we're really thinking about it, if this is a linear equation and I have h instead of y, that's totally fine. And we have m instead of x, which is also totally fine, because these are just variables that represent unknown values, right? So we can use any letters. But what ends up happening here is that we know that it's really plus a 0 here. So our y-intercept, if you wanted to dive deeper into this, is 0. And if I were to rewrite this equation, we're really kind of looking at y equals 3.5 x plus 0. So it's the same thing. These are equivalent. And our slope here, right, the slope for tree number 1 is 3.5. For the second one, we can calculate the average rate of change. If you remember the average rate of change, that is the same as your slope. Average rate of change is basically looking at the change of y over the change of x. So we're going to pick 2 points here. And I think I'm going to go with 2 months with a height of 5 and 4 months at a height of 10. And so I'm going to label this as coordinate points of 2, 5 and 4, 10. And actually what I'm going to do is label then these values with either x1, y1 or x2, y2. I'm going to label it with a different color so you can see x1 is going to be my 2 over here, and the 5 is going to be my y1, and then my 4 is going to be my x2, and my 10 is going to be my y2. So the change of y is going to be y2 minus y1. And the change of x is going to be x2 minus x1. And we're just going to plug in some values now. So I labeled y2 as 10. So I'm going to write a 10 here. I labeled y1 as 5. So I'm going to write the 5. I labeled x2 as 4. And I label x1 as 2. So I'm going to calculate my average rate of change, which is also known as my slope, and that equals 5 over 2, or if I wanted to change it to a decimal so I can compare it with tree number 1, this is really 2.5. But I like to keep things as a fraction. So I'm going to bubble that in. I'm going to write or equals 2.5. To help us compare it as a fraction, I'm actually going to change this 3.5 into a fraction as well. So this is really 3 1/2. And if I wanted to change it into an improper fraction, it's going to be 7 over 2. So I'm going to circle that. Alrighty, we're almost there. We're going to look at the slope for tree number 3. For tree number 3, we're going to pick 2 points again that lie at the corner of a square. So this dot here that I'm drawing in actually lies at the corner of the square. So I can even label this as 1, 2. And again, I can use the equation for the average rate of change or my slope as change of y over change of x if I wanted to. Focus on these 2 points that I had plotted, and I can even list this as x1, y1 for 0, 0, and for 1, 2, I can label this as x2, y2, and I can use this formula to find my slope. But graphically, I think it's easier if I drew in that triangle and calculated my rise over run. So I'm really rising 1, and I am running 1. So I know my slope is 1 over 1. And it's also a positive slope because if I put my person here on the left side and I'm looking from left to right, this person is going up. So my slope for this line is 1 over 1, or simply equal to 1. So which tree is growing the slowest? Well, if I were to compare all 3 numbers, you can either look at the fraction here, or if it's easier for you in this case to look at the decimal, we're going to see which number is the smallest one. Because when my slope is the smallest, that means that I'm going the slowest. That means for every 1 increase in time in months, for every 1 month, my height in feet is not going to be increasing as much. So that's why we're looking for the number that is the smallest for the slowest tree growth. And from what it looks like, tree number 3 has the smallest slope. So I'm going to write tree number 3 because it has the smallest average rate of change, or we know it as the slope. Also known as the slope. I'm going to write that as well in parentheses.